I popped the code for the workshop this week into the chat. Please, can you write it down as well, just so you've got it to hand? PRN 79099. For those of you that did join last week, you'll know why you need that code. I'll explain to those who didn't join us last week a little bit later on. And hopefully those of you that joined us last week and weren't signed up to Barefoot have had a chance to do that, and I'm hoping that everyone that's joining this week as well has signed up to Barefoot in advance. Don't worry if you haven't. We've got a bit of a workaround, but if you have got a Barefoot account, it would be great if you can use that when we get to that point. So right, let's make a start then. So as Louise mentioned, we're going to we've changed the format a little bit of the workshops from when we ran this course last year to actually extend this session across 2 sessions, just because it felt quite rushed in previous years, and I wanted to spend a little bit more time on it, particularly time on the activities for you taking part in the activities and having time on Scratch and time to ask any questions and share and feedback. So as Louise mentioned when we were sort of just getting ready to start there, I will, as we go through, ask if you don't mind, not at the moment, you don't need to, but as we go through the activities, to pop your cameras on, say hello, we'll have a bit of a chat and see how you're getting on with things. So this is the second of the 4 workshops in the series, and this one we're going to focus primarily on programming. And as we do that, we're going to be using Scratch, and some of you might have used Scratch before. Some of you might not have even heard what Scratch is. So I know that there will be a range in experiences that are joining us this afternoon. And I hope that whatever your prior experience, you can take something from the session, whether that be some of the kind of points around pedagogy, which I'll start going into and we'll develop further in our final session. Or if you're completely new to Scratch, just familiarising yourself with the environment and building confidence a bit in using it. In last week's session, we did get into a bit of programming at the end, but it was a sort of more younger age pupil focus, sort of 5 to 7 years. This week we're looking at slightly older, sort of the 7 to 9 year age range, but we're going to be using some of the kind of models and principles that we talked about last week, but I'll recap them for anyone that's just joining today for the first time. So right, let's make a start then. For anyone that didn't join last week, really quick recap about Barefoot, because everything that is being delivered to you comes from the Barefoot project. It was I'll whiz through this because I don't want to bore the people that heard this last week. But it was developed when the English national curriculum initially changed from ICT to computing, and where there was more computer science introduced. That was a good 6, 7, 8 years ago now. Since then, it's been Barefoot has been endorsed by Education Scotland and the other devolved nations' education departments. We map all of our resources to the various curricula, so that we ensure that they're relevant, not just for the English context, but for right across the UK. And we run free workshops just like this one. And through that, we've trained up close on 100,000 teachers now, and over 3 million pupils have been reached through our resources. So my role within Barefoot is director of the program now. So initially I was one of the authors who wrote the resources. I continue to do some of the writing of the resources and oversee the general program. So here's a recap on a key concept which we're going to keep referring back to from that we touched on towards the end of last week as well. What actually is programming? Let's set out a simple model of programming, and let's use this model as we go through this afternoon's session. Programming is a 2-step process. And I spend a lot of time in schools, including my own, where I teach on a Thursday and Friday. So I'll be doing my planning after this call tonight. And when I go into schools, I often see, I don't often see this kind of 2-stage approach being adopted. So this is something I'd really like you to kind of note down and try and use as a model for when you're planning and delivering programming lessons. There's two stages to programming. The first stage is design. This is exactly like when we do design and make something in engineering or design and technology. So we do a design for our program first of all. And with our design, we have an algorithm. So the algorithm is a specific sequence of instructions which sets out what our program is going to do. Okay, here the example we've got is it's represented in a storyboard form. There's no right or wrong way for writing down an algorithm. It's whatever works. And then we take our design and then we go and code it, and we call that second step coding. So when we're at the computer and we're working with Scratch code, that is called coding. But that whole process together, design and go and code it, is called programming. So we're going to use this model this afternoon in all of the activities that we do, and it's the model that I would really encourage you to use when you're teaching programming to your pupils. So where does programming fit in the Scottish curricula? Well, we've got the technologies strand, and we've got computing science within that, and the various sort of programming points are covered within this. There's the two subsections of understanding and analysing computing technology and designing, building and testing computing solutions, and that's the main points where it sits. It talks about at early levels things like understanding that sequence of instructions are used to control computing technology, and the first activity we're going to do this afternoon is all around that concept of sequence. Then it goes on to talking about understanding the instructions of visual programming language. Scratch that we're going to use is a visual programming language. And then it goes on up to the second level of talking about understanding and explaining core programming concepts. And we're going to look at a range of core concepts this afternoon and next week. And it's about, here the curriculum is split into those two strands of understanding and also then building and sort of applying that understanding. So not only understanding that sequence of instructions are used, but developing sequence of instructions, developing programs that use a variety of kind of core concepts as well. And if you then look at the benchmarks document, which provides a little bit more information around each of these, and you look at the different levels, what drops out of these is that there are three core concepts. In the programming world, they're called constructs. They're like Lego building bricks for all of the programs that you can make. And they are sequence, repetition, and selection. And going from left to right there, you've got a very approximate kind of progression. Sequence being the simplest through to you can do some quite complex things with selection. Now, it's really interesting. Whilst we're dealing in the space of sort of primary, pupils 5 to 11ish, but even if you drill down into some of the most complex programs used in industry, in computer science industry, you will find these three core concepts. They are the core building blocks of pretty much all programs. So this is what it boils down to, that we want pupils to be understanding in their programming experiences in school. So it follows that the way we're going to organise this week's session and next week's session is around those three concepts. And for each one, we're going to do some reading of code and some writing of code. So that's the first point that I'm going to make around pedagogy this afternoon. It's really important that we teach pupils not just how to try and write code, but how to read code. The way we teach a programming language really should mirror the way we teach a language, where we have that sort of parallel strands of developing reading and writing. And it's reading that is often is ahead of writing. And you wouldn't expect people to try and write without developing their reading, and you shouldn't do that in a programming context either. So we are going to spend some time doing some reading of code this afternoon as well. And in fact, I think that's where we'll start. So I'm aware that you might not have ever seen Scratch before, some of you, but that does not matter because it's a fairly easy programming language to read. So what I would like you to do is have a look at these two bits of code. I'm going to go quiet for a few minutes, a couple of minutes, and I'd like you to just pop into the chat any ideas you have on what these two bits of code might do when they are run. So these are two little snippets of code from Scratch. You might not have ever seen it before, but I reckon just by looking at some of the images, the words on these codes that are used, that you might be able to have a bit of a guess or a prediction. Hello. At what this might do. So please pop your responses into the chat. I will give you 2 minutes to do that. Brilliant. Super. Okay, thanks for that, Louise. That gives me a flavour of the responses there. And it sounds like that people have done a great job in sort of having a look at the code and anticipating what it might do. Obviously, I'm not sure whether people have used, level of experience previously, and it might be that this code is fairly familiar to you, or you might not have ever have seen Scratch before. But just by looking at the code, and it's kind of like catchphrase, say what you see. On the left here, well, it's going to say hello for 2 seconds, and then it's going to wait. By the way, it says that in a little speech bubble above the character that you're programming, for anyone that's less familiar. On the right-hand side, we can see the code starts with those pen tools, and this is just for drawing. Then if we look and we use our knowledge of maths and geometry, we can see that it's repeating 4 times a move equal number and turn 90 degrees. Well, that's going to give me a square, as you said. So we call Scratch, it's called a high-level programming language. And what that means is that it's easy to read. The commands give you clues. They literally tell you what it's going to do. A low-level programming language is when you're using, you're writing in text with abbreviations for different commands, a colon here, a semicolon there, and it's quite difficult to read unless you really know that language. But Scratch isn't like that, which is one of the reasons it makes it ideal for primary setting. Fab. Okay, thank you for that. So, right, sequence then. Let's start with sequence. And it is as simple as the name suggests. It is just about arranging instructions for algorithms and code for programs in a particular order. And one thing happens, A happens, then B happens, and C happens. So let's have a look at some examples. So some more code reading to start. At the bottom here, I have 3 sections of Scratch code, A, B, and C. And at the top, what I've done is recorded as a little GIF the outputs of these 3 codes when they are running, but I've jumbled them up. Your first task, and I'll go quiet for another couple of minutes as you do this, is to have a go at matching up 1, 2, and 3 with A, B, and C. So this is an example of a code reading activity. Have a look at what the code is, what it says it does. Have a look at what the camel sprite is doing and saying and how they're changing direction, and have a go at matching them. So over to you, and I will go quiet for a couple of minutes, and then we'll see how you got on. Okay, another 30 seconds or so. I'll give you a chance to practice your code reading of the sequence of commands. Fab. Fab. Okay. Yeah, and I think part of that as well, it's often quite difficult to be able to take that step back from your own code that you've written, that kind of metacognitive approach of thinking about your own work. So anything you can do like this and practice it, it really helps with kind of debugging. Would you, Louise, do you think anyone there might be willing to jump onto the microphone that's given us an answer and just talk us through how they got the answer?
No, yeah, that's fine. So yeah, actually, so when I first did it, I thought it was 1C, so I was wrong to start with, and I
Okay.
think the first thing I did when I was reading it was I was looking at the script, and I was
Yeah.
just going by the script, and then I quickly noticed that obviously the scripts are the same, and then you're looking at the direction, the movement of the sprite itself, and then the second time around, that's the two things basically as I read it. It was both the words, the script as it was put in order, and the
Yep.
sequence, and the sequence of movements as well.
Super. Thanks. Yeah. Thanks for sharing that insight into kind of how you went about things. Yes, we sort of deliberately tried to catch out. Sounds a bit mean, but just try and have an overlap between some of the samples of code in what is similar, so that it really encourages you to look more closely at the code that's there. Again, as Louise and I were just saying around kind of the debugging stuff, one things I notice with my pupils is that they're not very good at really looking. They just, and when I say really looking, when you're debugging code, you've literally got to step through it a command at a time, as opposed to just kind of looking at the block overall and kind of making assumptions or, kind of working at that level. So these activities encourage us to kind of go into detail. So thank you very much for sharing that, and to everyone else as well for having a go and popping your answers in. So what we're going to do now is we're going to have a go at writing our own camel chatter animation. Please, if you know any good camel jokes, please do include camel jokes in them. That's ideal. But to practice what I was preaching about the two-stage approach to programming, before we actually get into the the coding stage, I'm going to give you just under 5 minutes, 3 minutes should be fine, to quickly sketch out on a piece of paper in front of you an algorithm for your camel chatter animation. So here's an example. Just make it kind of 3 frames long, quick sketch of a camel with the speech bubbles. The camel sprite and the background are going to be in the program for you. So just sketch out what you intend your camel to say. We've got the best camel joke that I could come up with in the top left there. So it's now 16:25, 3 minutes, 5, 6, and 8. Couldn't do 5 plus 8 then. To 16:28. Have a quick go at drawing out your algorithm, and then I will share with you where you can get the program to create these. Okay, just another minute or so, and then I will show you where to get the pre-populated program to have a go at creating your animation from. Hopefully we've got some good... Sorry, go on, Louise. Yep, it is all about, this first one is all about sequence, getting it in the right order, and then translating that in the right order into our code. Super. Okay, so hopefully now everyone's got a algorithm ready to go. What I'm going to do now, I'm just going to copy the code here, is show you how to get to the program, the Scratch program, to turn your design into a program. So all you need to do is go to barefootcomputing.org, and you need to sign in. I've already signed in here. And all you do is you click at the top here, Workshops, Register Attendance. And here it's going to ask you for a code. And we're going to pop in that code, which I'll just say again for you, PRN 79099. And when you submit, click Submit, it will take you to a page where we've got links to all of the programs we'll be using this afternoon and next week. So the first one that you want is the Camel Chatter one. So if you click on that in a separate window, it will open up the Camel Chatter. Don't worry if you're not quite keeping up, I'll run through this again, but it will open up Camel Chatter, and then you just click See Inside. And when you do that, you will find yourself in a Scratch program where we've pre-populated it with the camel sprite and background. And we've provided a few blocks to get you started in turning your algorithm into a program, including the When Green Flag clicked block, which we can use as the start to trigger our programs, then a say block, which we know we can use to get the camel to say things, as you can see there, and a wait block. What you'll have to do is find and use the color coding, some more say commands and wait commands to then turn that sequence of speech into a program. So let me just show you again for anyone that wasn't 100% clear on how to get to that point, and also then for anyone that doesn't have a Barefoot account, I will provide a link to the program for you as well. But it's really simple. You go to barefootcomputing.org, and then you go to Workshops, Register Attendance, pop the workshop code in there and submit. and we're going to click on the top one, Camel Chatter, and go to Camel Chatter, click See Inside to actually see the code, and from here then you can start to build up your program. For anyone who doesn't have a Barefoot account, I'm going to drop this into the chat for you. There. And you can just follow that link. But as I said last week, please, if you do have a Barefoot account, go through that process of logging in and following the link, because that's just our way within Barefoot of registering your attendance and us being able to say that you're another person that we have worked with. So please do follow that route. Also, just to say, if anyone is joining us with a bit more experience in Scratch, we've got a number of different extension activities here for each of the activities we're going to do this evening. I'm not going to explain the focus of them, but if you go into them, I have added explanation notes and what you have to do in there. So if you want an additional challenge, please just go and click on those and have a go at those. So if you do have any questions about working in Scratch, if you are completely new to Scratch, please feel free to pop your hand up. I'm going to go quiet now for sort of 4 minutes or so through to about 25 to, and then we'll get someone to come on and share the program they've created. But in that time, please don't hesitate to pop your hand up and ask if you've got any questions about how you work in Scratch. It's simply a case of joining your blocks together. It's like digital Lego and altering what they're going to say. And when we want to run our commands, because we've got when green flag clicked, we can click over here and it will run them for us. So over to you, and I will go quiet for a couple of minutes. Okay, I'm just keeping an eye in case there's any hands up or any questions, but if I miss anything, Louise, do let me know. Just give everyone another minute or so, and then we'll see if anyone doesn't mind coming on and sharing what they have created. Okay, I think hopefully everyone's had a good chance to turn their algorithm into code, please pop your hand up if you wouldn't mind coming onto the screen and sharing with us the program that you've created in Scratch. If you just pop your hand up, that would be great, or we can do a bit of a pick of someone and see if we get anyone that wouldn't mind coming on. Oh, I think we've got Emma. Thank you. Are you there? Come on to the microphone, Emma.
I just realised, I don't know, because I'm doing it on the desktop and watching you on the iPad. Don't even ask why. So I'm going to use my iPad to film my desktop.
Yeah, perfect.
Makes sense?
Yeah. Louise and I were just talking before about last week we were talking about all the different permutations of using different technology and stuff. So
yes.
This is a good example. That looks fantastic, Emma. Right, would you mind just talking?
I don't know if you can see it.
Yeah, we can, yeah.
So I added another, well, first of all, I changed the language. But first of all, I added another weight after the last thing the camel said, after the last thing the penguin said. Yeah. And then checked that the timings were longer than the other animal was going to be waiting, so they wouldn't be talking at the same time. Okay. And then there's a response, and then that wait response is timed to be before the next one comes up. I don't know if I explained that very well.
Yeah. So you've added a second sprite into yours, have you?
No. There's already the penguin.
Is there?
Are you doing the extension? I think I might have done this wrong now.
No,
sorry.
No problem at all. Apologies, it's me getting confused. So I've forgotten that the penguin's in the extension one. Yeah. Okay, so you're doing the extension challenge, and that's really a sort of focus on getting two things to sequence correctly as opposed to one.
Sorry, I think I jumped the gun a bit.
No, that's fab. That's absolutely fantastic. Thank you very much for sharing. It looks great. Can we see it play? Can we see?
Yep, right.
That's it. Zoom in for us. Hey.
Yeah. Oh, hi. I'll try and get close. Hang on, sorry.
I've just relocated. I fancied a bit more sun.
Sun. See, that was there already, yeah. And then he thinks about it. And then he's like, oh, it's hot. And then he's like, yeah, it's hot.
Fantastic. Round of applause. Excellent. And thank you for coming on, Emma, to share that. That's great. Thank you. Okay, so let me go back to my screen share as well. Jump back to here. So there we go. So that was sequence. So it's fairly straightforward. It's about getting things in the right order. The extension there is the idea of sequencing more than one thing in Scratch, where you have animations. I think the Bear for Activity does a knock joke between two characters that you have to sequence together. But it's a simple linear start at one end, finish at the other. Let's now move on to our second concept, and this is the last one we're going to cover this evening, and we'll come on to the final one next week. But this is repetition. Now, we use repetition all the time in programming, and it's a misconception that I see time and time again with pupils when programs don't work as they expect them to. It's often that they've left out repetition blocks that they need to include. Repetition, again, is as simple as it sounds. It's just about repeating certain instructions or commands in a program. So you might hear these called loops as well. There are different types of loop, as we're about to look at. And we also can start to use, as we go into kind of older age groups, 10, 11, 12, we start to use loops with our final concept, which we'll come on to, called selection as well. But let's just start by doing a code reading activity again. And before we do that, I just want to quickly explain to anyone that's not familiar with it the concept of costumes in Scratch, because what you're about to see is camels come dancing with a camel doing a dance routine, and you're going to have to match it up with the code for that dance routine. Now, just to say, the way that we get the camel to do these different dance moves in Scratch is to use a costume, different costumes. So this is just one of the commands available in Scratch, where you can get a sprite to have different appearances. So we've got different graphics for the camel. We've got looking left, looking right, doing a handstand, doing the Disco Fever John Travolta move, doing the splits, doing the spin, and doing, what was the final one? I'm trying to remember now. It's, oh yes, Pulp it's called. It's the Pulp Fiction eyes, fingers in front of the eyes move. But we just called it Pulp because I realised that having the word Pulp Fiction probably wasn't appropriate in primary based materials, just in case anyone realised what the connection was. So here we go. Same as before. Look at the code. We have included two different types of repetition commands now, and that's the focus here, the repetition commands in our snippets of code. Can you again match ABC to 1, 2, and 3 by looking at what the camel is doing, and particularly how many times it does it? What are with the repetition commands? So over to you. Give you a minute or so, and as always, Louise, when you see a few starting to come through, if you can let me know, and then we can have a discussion about them. Two, 2A, 1B, and 3C, Mr. Turnbull thought. Is that right? Right, okay. 1C, 3B. Okay, thank you. These are looking good. Is we got Miss Wilkinson? Just that was a name I remembered. Then are you there, Miss Wilkinson? Mrs. Wilkinson.
Hello.
Hello.
Yes, hello.
How are you doing?
Fine.
Thank you for coming onto the microphone. Would you mind talking us through what you've got and how you went about, with activities like this? It's always good to kind of get into the mind of the pupils and get them talking about what they did to try and sort of reveal their thinking. Would you mind just sharing how you went about matching them up?
Well, I looked at number 1 was going left and right, and then doing Disco Fever like over and over again. So that was on forever.
Ah, fab. Okay,
so that's how I got the first one.
Yeah,
and
super.
Then the next one, 2A, I think. Yeah, 2A. It looked like it was doing a handstand.
Yep.
But it wasn't on. The handstand wasn't on forever. The repeat 2 times, so it went left and right 2 times, and then it did a handstand, I think.
You are right.
2A,
I think.
And then 3B was what was left. So I just checked that it did the splits twice.
And I'm just watching it there, and it does. So yeah, that's super.
And then so that matched up.
Yeah, excellent, super. Thank you very much, and thanks for talking about the difference there with the different repetition commands. So you saw that C has got a forever loop on it, and A and B just use the repeat fixed number of time loops. So those are two different types of loops that we would use in our program at the kind of ages sort of 7, 8, 9 level. When we get into slightly older, as I said, we'll use something called conditional loops as well, which have conditions in them. But this is another code reading activity to get you diving into that code, having a look at it, having a sort of understanding of what those commands do, what the repeat commands make the sprite do based on the matching with the top. Now let's have a go at doing a code writing activity. And before we do that, I just talk through, I mentioned at the beginning, algorithms can be in whatever form you want them to be in. So just to talk through different ways that you could perhaps do the algorithm for an activity like this. We're going to do in a second number 1, which is a sort of text-based algorithm where we just write out the different moves that we want the camel to make and sort of label it up with arrows and repetition notes on how it's going to repeat. But you could do something like getting pictures of the camel, striking the different moves, cutting them out, and then arranging them together and annotating that with notes on how it will repeat. Or you could actually get pupils to do the drawings themselves. When we did this session as a face-to-face session a while ago, we also had the option of pairing people up, and one of them danced in the way that they wanted the other person to code the camel to dance. So you could introduce a nice little bit of dance and drama into your lesson as well there. So it really is up to you to use a variety of methods for creating algorithms, and ones which play to the strengths and help pupils develop whether they're writing or drawing, etc. But what I'd like you to do is use that first method. Here are the different dance moves which are in Scratch, which are going to be available to you. So 2 minutes having a go at writing out your dance routine for your camel in the text form. I've got an example there on the right where we've got repeat this 2 times, looking left, looking right, repeat this 3 times, spin, disco, polk, and then the whole thing repeats forever. It can be as simple as complex as you like, but I'm going to go quiet for a minute or so, and then we'll jump into Scratch and we'll start turning some of these into actual dance routines. Okay, just another 30 seconds or so. Try and use as many of the different dance moves as you can, and use your different types of repetition command as well. Okay, right, so hopefully now everyone's got an algorithm that they can turn into a program. So again, if you go back to this page and go to the second one, Camels Come Dancing, it will take you through to a Scratch file, and you can click See Inside. And just before I let you get on with creating your dance routine as a program, just to explain a bit as well about the pedagogy, about how we've been structuring and scaffolding things this afternoon. The first Scratch file that I gave you had the sprite in the background in and a couple of blocks as well. I often do that with my pupils so that loads of time isn't spent just on deciding which sprite and background to use, but we actually get straight into the kind of coding part. And here what we've done is we've actually included an example dance routine which you can then modify to turn into yours. So this is again another approach that I might use, giving them an example and getting them to change things. It's called sort of use, modify and create. We'll talk more about it in that final session around pedagogy. But it's like when we're doing writing activities, we don't always just give them a completely blank sheet of paper. We give pupils example text that they can pick apart or they can modify and improve, etc. And it's kind of the same theory there. So I'm going to go quiet now for 3 or 4 minutes, and I'm going to let you have a go at pulling this example dance routine apart, using what you've got there and turning your algorithm into a dance routine. So over to you. Excellent.
I tried to mess about. I didn't have time to mess about with making it go faster on the looking left and right. So do a slow look left, right, and a faster look.
Yeah.
I think you'd have to kind of slow down the first ones.
Yeah, have a bit more of a distinction between them. Yeah, that's great. No, thank you. And I can see that you've used, different types of the repetition commands, from the fixed number of times ones to the forever ones as well. That's super. Thank you very much for sharing. Okay, I will just grab the screen back. Oh, where can I find the when click? Oh, okay, yeah, good point. Let's just share that from Mrs. Matthews. I'll just cover this off as we finish. So we deliberately leave it out in this activity, but only because I'm supposed to explain what I'm about to explain, and I didn't, so it doesn't really work. So the when green flag clicked block you'll find in events, and you can use that to start code. However, in Scratch you can also run code by simply clicking on it. So you don't always need the when green flag clicked if you just got a bit of code that you want to run, and this is really handy when you're coming to debug things by breaking it down into parts. You might just want to test this bit here or this bit here. Just click on it and then it will run that bit of code. But if you want the green flag one to place at the top where you've got it all together and you want to run it all at the same time, you can get that from events. So there you go. Sorry, Miss Matthews, that I might have hindered you in doing your dance routine there. Right, let's just jump back over to the display here. So that was repetition. Straight, it is simple as it sounds. It's about using different repetitions in our programs, whether that be fixed number of times or repeating things over and over forever. What we will cover next week is the final concept of selection, and this is the powerful one, really. This is where we get computers being able to respond differently to users depending on what those users do. So it doesn't always, with sequence and repetition, it's just you start it and off it goes. With selection, you then bring in that ability to interact with programs. So we'll cover that next week.